So, good evening, everyone. This is lecture number 3, and we are dealing with refraction at plane surface. The last class we had dealt with the glass slab. We had seen the lateral and the normal shifts because of a glass slab, and I think I showed you the question that came in JEE, and I asked you what will happen if there are n number of glass slabs put one after the other. Yes. Can you tell me? Some of you tried probably. If you have n number of glass slabs like this, what will be the total shift? Yes. The object is here. Now I'm going to observe the object from the other side of the n slabs. Eyes would be here. What will be the total shift? Yes? Anyone? What will be the total shift? Are you telling me or should I tell you? No one is telling me. Is anyone going to tell me or should I do the needful? Should I tell you the answer? Yes. Do you remember what we were discussing in the last class? How many of you remember it? 1, 2, 3, 4. That means most of you have not even looked at the book before coming to this class. Yes?
T1 into 1 minus 1 by mu1 plus T2 into 1 minus 1 by mu2 plus T3 into 1 minus 1 by mu3.
Okay, that is correct. So if I call the displacement due to this one as x1, if I call the displacement due to the second as x2, x3, and so on up till xn, the total displacement, my dear friend, the total shift would be x1 plus x2 plus x3 up till xn. So we just have to find out the shift due to one of the slabs, shift due to all of the slabs, and simply add them. Do we understand this? And how will you find out the value of x1? You just put in this equation, instead of x, you put x1. In place of t, you put t1. Instead of ur, you put u1. And that is how you end up finding out the total shift. Do we understand this? Yes or no? Can I have raise hand from everyone that we have understood this concept?
Yes, sir.
That is how you can find out the total shift due to many slabs. Okay, the next heading that we are going to write is the concept of optical path. Now, this optical path may not come now to us, but it will come very handy in the chapter on wave optics. Optical path. So it's good if we can discuss it now and then we can probably remember it. Anyone has any idea about what is this optical path? Anyone has any idea what do you mean by optical path? The dice is open. You can share your thoughts. What do you mean by an optical path? What do you mean by optical path? Yes, bacha?
Passing through optical.
Passing through optical path, I don't understand what I
Optical axis.
on an axis. Axis, no, they got nothing to do with axis. Now, whenever light travels in some medium, the speed of the light is different. Yes or no? Whenever light travels in some other medium, the speed of light is different. Yes or no? Do we understand this?
Yes, sir.
Now, when light travels in a medium, the speed of light is different. compared to vacuum or air, is the speed more or is the speed less? The speed in the medium is less. Now, whatever time the light travels in the medium, if you compare it, how much distance it is going to travel in vacuum, that is known as your optical path. It is defined as the distance traveled by light in vacuum in the same time in which it travels in a given medium. That means it is an equivalent distance of what light would travel in vacuum if it travels a distance x in a given medium. Do we understand this? In simple terms, what we need to understand is how are we going to find out the optical path, and that is the only thing that is important to us here. How do we find out the optical path of light? And this is how we find out the optical path of light. So basically, if light travels a distance x, this is a medium of refractive index mu. Do you see this? If it travels a distance of x in a medium of refractive index mu, then the optical path is mu times x. This mu times x becomes your optical path. This is the distance light is going to travel in vacuum in the same time. Do we understand this? That is the only thing that you need to understand. You just need to draw this diagram. If light travels a distance x in a medium of refractive index mu, then the optical path is given by mu x, which is the distance it will travel in vacuum in the same time. Do we understand this?
Yes, sir.
Now, if I have two glass slab or an n number of glass slab and it travels x1 in the first slab, x2 in the second slab, refractive index is mu1, mu2, mu3, mu4, and so on. The optical path length, we will add up all these path lengths, mu1 x1 plus mu2 x2 plus mu3 x3 and so on. Do we understand this? That is the only thing that we need to remember about optical path. Optical path is the equivalent distance in vacuum for a given distance in any medium of refractive index mu. I'll give you 1 minute to note it down. Have you noted it down, beta? Remember, here we are dealing with uses of. Yes, beta?
No, sir.
I'll give you time, don't worry. We have time on our side.
Completed, sir.
Completed, sir? Pakka na, sir?
No, sir. 1 minute.
Sir, done, sir.
No, sir.
Okay. Shall we move ahead in life?
No, sir.
Yes,
No,
sir.
sir.
Yes, sir.
No, sir.
Yes, sir.
No, sir.
Done, sir.
Done, sir.
Okay. Okay, so the next heading that we are going to write is something that you probably have heard about. Case number 3, application number 3, real and apparent depth. Have you heard about this? Real and apparent depth. What do you mean by real depth? What do you mean by apparent depth? Now, basically, it is similar to what we have done, normal shift, and I will show you how this is same as normal shift. It is exactly same actually. Not even, it is exactly same in that case. Now, if you have an object placed in some other medium and you're observing it from some other medium, the best example is you put something inside water and you try to observe it from outside. Does it look at the same depth when you watch it from air? Does it look at the same depth? Yes or no?
No, sir.
No, it does not look at the same depth. Why it does not look at the same depth?
The rays will be bending, na, sir.
The rays bend, and depending on from where you are watching it, it might look raised up or it might look further down. Depends on how from where you are watching it. If I take the example of something is in a denser medium, and the best example of denser medium is water. Something is inside water. Water is denser as compared to rarer medium air. So the actual object is here, O, and the depth of this object is DAC or D actual or DI, whatever you want to call it. This is the actual depth. But when the rays pass from water to air, they are moving from denser medium to rarer medium, and therefore they will bend away. Do you see them bending away? Yes or no?
Sir,
Because, yes,
sir,
beta?
can you draw the diagram really?
Yes, the diagram
Instead
is
of
here.
placing the slide, can you draw the diagram?
The
We can
diagram, you
understand
can't draw the
better.
diagram?
Yes, sir. We want diagram.
Draw it.
Huh? Sir, we want you to.
Okay. The object is in the denser medium and we are watching it from the rarer medium. So what happens is lights will get bent away from the normal and the object appears to be raised up. That is known as the apparent depth. Right? Real depth, apparent depth, what you got to draw is just draw a single line, and that is good enough. This is the object and it will appear here. Just you need to draw this, nothing else. The object will appear here. Do we understand this? The object will appear a bit raised up because of ray traveling from one medium to the other medium. Do you have any problem with this, beta? Or the diagram is looking too complicated? Is that so? Diagram is looking complicated? This is a very illustrative diagram that I have shown. If you want, I can show you a different diagram. Okay, this one is better. This one is less complicated. Okay, I will put it here so that you can see this one. Doesn't matter. You have to draw them as simple as possible. Okay.
Sir,
Simple lines. Yes. Yes, beta.
sir, if you draw, we can understand more easily, sir, other than screen sharing.
Yes. Sorry.
Sir, don't make the screen sharing. Draw the diagram, sir. By that, we can understand the rays and where is the image.
You just have to write this point O. Nothing else, beta. This is point O. This is the actual depth and this is the real depth. Nothing else. Other diagram is not at all important. You just have to understand what is real depth and what is apparent depth and what is X. Nothing else. Got my point? We don't have to look at the diagram. You just have to draw this simple thing. One is the object This is the real depth and this is the apparent depth. Rest all is not important. This angle R, this angle I, this is not important at all, because we are not going to get into the theory of how it is derived, because that is a part of your board thing, which we cannot spend more time on it. Do we understand this? We just have to get the relation, the correct relation, and we have to solve question based on that. That is all that we need. Because if I try to explain the entire diagram and derive it, I will take the entire class with, and we don't have so much of time. Do we understand this? So we just need to understand what is real depth. This is real depth, the actual depth, and this is the apparent depth. Nothing else. Nothing else we need in the diagram. Do we understand this? Do we understand this? Yes or no?
No, sir.
Okay, we don't understand this. Well done. I will draw the diagram. Not a problem. So draw the diagram now. This is the surface. This is the ray which is going, and it appears here. So this is the object O. This is O dash. This is dr, the real depth. Dr, the real depth. And this is dA, the apparent depth. This is one medium, you can call it mu1. This is the other medium, you can call mu2. So draw the diagram. That's it. Object is in one medium and you are watching it from the other medium. So eyes are here. Okay. Draw it. So we have real depth, we have apparent depth, and this distance is known as the shift or x.
Sir, in which direction the rays are going, sir?
Yes, beta?
The direction of rays.
Sorry?
Direction of rays.
Direction of rays. The rays can go anywhere because object is here. The rays will go from here in this direction. The rays will come from the object, no beta. So rays goes like this. See, try to understand there, beta. We don't have to derive the entire equation. Are you getting my point? Don't have to derive the entire equation. We are not here deriving the entire equation. We are just here to understand what are the meaning of the terms and use them to solve questions. That is what we are trying to do here. Okay, so object is here. So the rays will go in this direction, right? And it is what I have drawn is this is a rarer medium. This is a denser medium. This is a denser medium and this is a rare medium. So it will appear to be raised up, nothing else, because light will bend away. Light bends away like this, and it will appear to come from this point, nothing else. Don't have to understand that much better, because the way we will remember this concept is what is important. Diagram here is not important. Do you understand this?
Yes, sir.
You just have to draw a representative diagram that you understand the terms that are coming in that equation. Because the way I will give you the equation, it doesn't matter whether it is going from rarer to denser or it is coming from denser to rarer. Okay? That is the way I will give you the equation. And that is what is important, nothing else. The complexity of the diagram, the different terms, what is I, what is R, we are not deriving it. No point of it deriving it. No one is going to ask in the JEE, derive that formula. No, they will ask you the question. We are more concerned about solving the question rather than getting in the complexity of deriving the formula. Okay. So have you written the terms? dr, real depth, dA, apparent depth. Mu1, the refractive index of the medium. Mu2, refractive index from where you are watching it. Shall I move ahead?
Yes, sir.
Okay, so you now need to remember this relation dr by dA. So you can remember it in many ways. dr by dA is equal to mu 1 divided by mu 2. That is the relation that you should remember, my dear friends. That's all that matters. dr, real depth divided by apparent depth, is equal to mu 1 divided by mu 2. Now you can remember it in many ways that you feel like. You can remember it like this. Oops, wrong color. Why I'm using wrong color? dr divided by mu 1 will be equal to d apparent divided by mu 2. Nothing else. Do we understand this?
Yes, sir.
That's all that we need to remember in this formula. So now I can write this formula in this way also. Real depth will be given to you. We are supposed to find out the apparent depth. So how can you write the formula for apparent depth here? D apparent will be equal to d real into mu 2 divided by mu 1. Yes or no? So you can remember this formula in this way also. Can remember this formula in this way also. Why is everyone moving so much? Everything is okay?
Okay, sir.
Okay, so this is another way of remembering this formula. This is way number 1, this is way number 2, this is way number 3. Apparent depth is real depth into mu 2 by mu 1. Now remember, this formula does not depend on whether it is going from denser to rarer or it is going from rarer to denser. In all the cases, this formula remains same. Do we understand this?
Yes, sir.
Okay, this is the formula for apparent depth. Now, if I talk about this x, that is important, x, this x is the shift. Do we understand this x is the shift? This x is the shift. How much it has shifted? Yes or no? This x tells me the shift. How will I get the shift from here? How will I get the value of x from here? And that is what it is important. How do I get the value of x from here, which is the shift? The shift will be real depth minus apparent depth. Do we understand this? So I can write it like this: d real into
DR
1
minus DA.
minus mu 2 by mu 1. Yes or no? 1 minus mu 2 by mu 1, or I can write it in this form: dr will be equal to 1 minus 1 by mu relative. What is this mu relative? This mu relative will be equal to refractive index of first medium divided by refractive index of the second medium. Do we understand this? So now this becomes
Sir.
your x, which is the shift. And what I was telling you, beta, that this concept is same as what we had done in the case of that normal shift. Now, if you look at this formula,
Sir.
oh, sorry, I forgot to share it. Okay, so I'll repeat it. X is the shift. Let me just put it here. X is the shift. This X is real depth minus apparent depth. So I can write it as real depth minus apparent depth will be dr into mu2 by mu1. So it becomes dr into 1 minus mu2 by mu1. So x becomes 1 minus 1 by mu r, where mu r becomes equal to mu1 by mu2. So this x, which is the shift in this case, if you compare it with the previous formula that we got for shift due to a glass slab, both the formulas are same. Do we understand this?
Sir.
So
Yes,
that
sir.
means that we are dealing with the same thing. Yes, beta. Shall I explain it again?
Yes, sir.
Okay. So I'll rub it out and I will explain it again. So this x, which is the shift, is dr minus dA. Do we understand this?
Sir.
Dr minus dA is your x. You just put the value of dr, you just put the value of dA. So you will get dr into 1 minus mu2 by mu1. Because dA is dr into mu2 by mu1. I can write this as dr into 1 minus 1 by mu r, where this mu r becomes mu1 by mu2. And now this formula starts to look same as the formula that we created for the shift due to a glass slab. Both the formulas are same. So if you can remember any one of these, you can remember the other one, which is what is important. This entire thing, what is important is that you understand what do you mean by real depth is the actual distance. Apparent depth is the distance that you see. And then you have to remember this form. Is it clear to everyone?
Yes, sir.
Okay.
Sir.
I'll give you 1 minute to note it down. Yes, beta. Tell me.
Done, sir.
Yes, sir.
Yes. This is the diagram. The only thing you have to remember in the diagram is the value, what is
Done,
dr,
sir.
what is dA, and what is x. And then you have to remember the three formulas that I have given you. Has everyone noted it down?
Yes, sir.
Pakka?
Pakka, sir.
Pakka?
Yes, sir.
Then we will solve a question and let us see if we can do this. Remember, questions are going to be pretty simple. Don't get confused by the questions. Questions are pretty simple. They won't ask you to draw the diagram. This is not required. You just have to remember the concept and make your own ways of remembering the concept. So this is the question. An object lies 100 centimeter inside water. It is viewed from air normally. Find the apparent depth.
Chapra.
Yes, beta.
75 centimeters, sir.
Yes, beta.
75 centimeters.
Is it more or is it less?
Less.
Why it is coming less? Because it is moving from denser medium. The object is in the denser medium and we are watching it from the rarer medium. Do we understand this?
Yes, sir.
Understand this? The object is in the denser medium and we are observing it from the rarer medium. So how do we do this? There are different ways of doing this. Whatever way you remember, you can use it this way. I will remember this one. D apparent is equal to dr into mu2 by mu1. Right? How much is the real depth? That is 100. Water, the refractive index of water is not given. It is, I think, 4 by 3. Yes or no? Refractive index of water is 4/3. Yes or no? Yes or no? This was not
Yes,
given
sir.
in the question. It is 4/3. So mu2 is air. Its refractive index is 1. Mu1 is water. Its refractive index is 4 divided by 3. So here I have my answer. 3 will go in the numerator. 100 divided by 4 is 25. My answer would be 75 centimeters. Do we understand this?
Yes, sir.
So doesn't matter from where to where the ray is going. If you remember that simple formula, that should be good enough for you to understand this. How many of you got this answer? Tell me. Please
Yes,
raise your
sir.
hands. Last bench, front bench, girls, boys, everyone. Okay. One more. And remember, if you can do any one of the questions, that means you have understood the concept correctly. You don't have to do it any further. Now, let us solve this one. And in this, the case has been, I think, reversed. An object lies 90 centimeters in air above water surface. It is viewed from water normally. What is the apparent height of the object? What is the apparent height of the object?
One 120, sir.
So it is coming more. Why it is coming more? Because the object is in the rarer medium and I'm watching it from the denser medium. Doesn't matter how the object is and where is the object placed. If you've understood the meaning of those terms that have come in the equation, you should be able to solve this question. Yes or no?
Yes, sir.
Everyone could do this?
Yes, sir.
So how to do this? Again, we apply the same formula. Remember, it does not matter from where to where it is going. I apply apparent depth is equal to real depth into mu2, second medium from where I am watching, divided by the first medium in which that object is kept, 90, multiplied by mu2 is water. I'm watching it from water. Refractive index is 4/3. This is kept in air. Refractive index is 1. That is your answer. 90 multiplied by 4/3. And I think the answer will come as 120 centimeters. Yes or no?
Yes, sir.
Pakka?
Yes, sir.
Anyone could do this? Please raise your hands. I don't see the hands of all the students. Anyone got this? No? Pakka? Otherwise, this entire exercise goes in vain if you don't understand it. Now comes the question. See, as I told you, even in JEE, the question gets repeated sometimes. This was in the year 2001, and I showed you the question from 2022. Yes or no? Yes or no?
Yes, sir.
Then, sir, answer, sir. Don't have to write the entire question, sir. Now, if you want to write, you can write it. A ray of light passes through 4 transparent medium with refractive index mu1, mu2, mu3, mu4 as shown in the figure. The surfaces of all the mediums are parallel. If the emergent ray CD is parallel to the incident ray AB, what does that mean? Remember, it's a very simple question. Let's see if anyone can give me the answer to this one. This IIT-JEE, no JEE Mains, no JEE Advanced. This is IIT-JEE. Yes, my dear friends, do we have an answer? If this question requires copy and pen, that means the entire class that we did in the last class goes down the drain. And right now it is somewhere in the Nala and going towards that sea out of Hyderabad. Yes. And the answer is
mu4 is equals to mu1.
mu4 is equal to mu1. That is the correct answer. That is the correct answer. And how did you get it? If you just pay attention in the class, you should be able to solve questions from IIT-JEE. This IIT-JEE now means JEE Advanced. I don't consider JEE Main as an exam. Okay, do we understand this? Yes or no? Everyone got the answer? How did we get it? For this ray, the pink ray, incident ray, and the green ray to be parallel, both the medium should have the same refractive index. Yes or no? I told
Yes,
you
sir.
that. Yes or no?
Yes, sir.
But that's the
Sure.
concept that you have to apply. Once you apply that concept, everything else is pretty damn simple. Yes or no? No, yes. Again,
Yes, sir.
as you can see, questions from the IIT-JEE. That is the IIT that I gave. Comes one more. And again, this question will remind you of the question that came in this year's JEE. When I say JEE, I mean JEE Advanced.
Sir, show the previous slide.
Yes?
Show the previous slide, sir.
Show the previous slide. It is not a slide, first of all, beta. I'm not taking this on a presentation, so this is not a slide. You can say screen. Why it is taking you so long to write this? Don't have to write. See, if you are wasting your time in writing the entire question, that is a waste of time. Just have to draw the diagram, that's it. Okay, write it anyways. Just have to draw the diagram and just write the question. If you write the entire question, beta, we'll be wasting a lot of time. And time is a luxury that we don't have. Yes or no? Anyways, write it.
Done,
Just
sir.
have to draw the diagram. Just write. You don't have to do anything. Just write 4 slabs.
Done,
Mu
sir.
1, mu 2, mu 3, mu 4. Emergent ray I is parallel to incident ray I is parallel to emergent ray. What is the answer? Mu 2 is mu 4. Mu 1 is mu 4. Got it?
Yes, sir.
You have to be fast, beta.
Done, sir.
Time is not on our side. I hope you understand this. We are way behind the course schedule. Do you know this? Do you know this? We are way behind the course schedule. Anyways, here comes the next one. See, even if we are behind the course schedule, but that doesn't mean that we cannot do practice. But you'll have to be faster. Because if you are slower, we'll be doing less question in the class. And if we do less question in the class, that means less practice. Okay, will we get this? Yes or no? Slower means less practice. A ray of light is incident at a glass water interface at an angle I. It emerges finally parallel to the surface of water. Then the value of mu glass is, find the value of mu glass. Let's see who can do it fastest. Fastest finger first. I think Conmeda Kurupati has started. Fastest finger first. Let's see who gets the fastest finger first round. Yes. Fastest finger first. Anyone? No one? How many refractions are happening? Shall I help you out? I hope you can see the question. Yes or no?
Yes, sir.
Let's not waste time in writing the entire question. Just draw this diagram. You have to be fast. Don't waste the time in writing the entire question, bacha. Don't have that much of time.
4 by 3 sin.
4 by 3, sir. No, sir. Because 4 by 3, sir, is the
4 by 3
refractive
sin
index
I.
of water, sir. And it cannot be both the same for water and glass, sir. Because then angle would be same, sir. 4 by 3 sin I. You got the answer. Well tried. See, getting a wrong answer is not a bad thing. But not trying is the worst thing that you can do. Okay, shall I solve it for you now? Yes or no? No, yes.
Yes, sir.
Yes, sir. No one got the answer, sir. Okay, see, this is how you apply what you have learned in the class in questions. Do you remember this? Mu into sin I is constant. Do you remember something like this? I told you sometimes back. 2 classes back, right? Yes
sir.
or no?
Yes, sir.
That's it, sir. That is the answer, sir. Now, let me call this as number 1, let me call this as number 2, and let me call this as number 3. For number 1, mu is mu of glass into sine of I. That should be equal to number 2, mu of water into sine of R. That should be equal to number 3. That is how you solve question of the JEE, my dear friends. And that is the reason that I did not solve the question of JEE Advanced 2022. Well, once you solve this, you should be able to do that question on your own. So mu G into sin I will be equal to mu W into sin R. That will be equal to
Constant.
mu G into sin I, number 1, is equal to mu water into sin R, number 2. That will be equal to what?
1, sir.
That will be equal to mu of air. Third, mu of air multiplied by sine of the angle in air. And what is the angle it makes in air, my dear friends? It emerges parallel to the surface. That means the angle is 90 degrees. Do we understand this?
Yes, sir.
And sir, if you look closely now, sir, this is equal to this. You get your answer straight away, sir. And the answer is this one, sir. It has got nothing to do with 4 by 3, sir. This is how you apply what you have read in the class to solve questions of the JEE, my dear friends. Do we understand this better? Please raise your hands and let me know that we understand this. Boys don't seem to understand. Boys, are you there? See? Remember, I have told you much more than what you will ever need to clear any exam. Ever. The only problem is, can you apply it when it is required? Can you use what I have told you to the best possible way? If you can use it better, no one can stop you from clearing the exam that you are intending. Everybody understands this, yes or no?
Yes, sir.
Chalo, one more.
Yes, sir.
And I hope that you can solve this one. Here it comes on your screen. Now, an air bubble in glass is 6 centimeter deep when viewed from one face and 4 centimeters deep when viewed from the opposite face. 10, 10, 10, 10, 10, 10, 10, 10. What is the thickness of the glass plate? 10, 10, 10, 10, 10, 10, 10, 10.
15 centimeters, sir.
That means you have solved the question before. Well done. Or you have solved it just now. Say. Now did you get 15?
Yes, sir.
You solved it before or you solved it now? Say na.
Before, sir.
Before, sir. So that's what we call hard work. Where did you get this question? From the sheet that I gave you? Or
Yes,
somewhere
sir.
else? Okay. Now that is how you don't get lucky. You don't call this getting lucky. You call this using the hard work, utilizing the hard work. The more the number of questions that you do, my dear friends, the more are the chances that you will find similar questions appearing in your exams, whether you talk about JEE, you talk about NEET, or you talk about any exam in this universe. Okay? So I'll give you time for the other students. Just like me, I have not solved this question before. I've become lazy these days. I don't solve many questions that I should. The only reason being I don't have to appear in an exam. And that is the reason that I don't do it. But that doesn't stop others to solve it. Anyone got this, girls? I think girls are getting more into the groove of solving the question. Boys are a little bit fragile. Is that so? Girls are taking the lead. That's why I like girls, because they are more hardworking, more dedicated, more sincere. And I can see that because I know that they are also solving the exercise that I have sent them. And see, the hard work is going to show. Yes, my dear boys. Having said
Yes,
so much
sir.
about you, please come up with something. Yes, Bacha, tell me. Yes, Bacha, got the answer?
Yes, sir.
Well done, sir. Where are you, sir? I can't see you, sir. Please raise your hand, sir. Boys? Oh, last bench. Last bench coming to the picture. What about the front benchers? No. Front benchers should be doing it faster than the back benchers, or everyone should do it together. Now, how do you do it? The diagram is there right now. So from one side you see it as, oops, wrong color. Why I use wrong color? From one side you see it as 6 centimeters. From the other side you see it as 4 centimeters. Yes or no? These 6 centimeters and 4 centimeters are, my dear friend, your apparent depth. Yes or no? Yes or
Yes,
no?
sir.
Okay, let me call the total slab thickness as T, and let me call the length or distance from here as X. So now let me call this as case number 1. Let me call this as case number 2. Now let us put it for case number 1. Case number 1, tell me what is the real depth, what is the apparent depth. My apparent depth is 6 centimeter, yes or no?
Yes, sir.
So apparent depth is equal to real depth into mu2 divided by mu1. I put the formulas very correctly. What is my apparent depth here? What is my apparent depth here?
X.
X, my dear friend, is the real distance that X is the real distance. Do you understand this? What I see is the apparent one. What do I see? I see them 6 centimeter away. Yes or no? So, my dear friends, 6 centimeter is my apparent depth. Yes or no?
Yes, sir.
My real is X. My mu2, from where I'm watching it from here. So that is 1 divided by
1.5.
Where is the object? Object is inside glass, so 1.5. Do we get this? Yes or no? No, yes.
Yes, sir.
I've not done anything extravagant. I have just put the value of XR, mu2 and mu1. This is case number 1. Now I'll do the same thing in case number 2. Now tell me, what is my apparent depth in case number 2? What is my apparent depth in case number 2?
Four.
Tell me, fatapat.
4.
Yes.
Centimeter.
How much?
4
Four.
centimeter.
Well done, 4. What is my real depth in case number 2? See, bacha, the
T
total
minus
is
X.
T. The total is T. Yes, what is
T
the real
minus
depth?
X.
T minus X. Well done. What is the value of mu2? I'm again watching it from here.
1, sir.
Remember, I could have changed the question and I could have put water here. But even if there was water here, doesn't make any difference because instead of air, I will put the refractive index of water. Do we understand this?
Yes, sir.
Doesn't make any difference. Okay, right now it is air, so it is 1 divided by the inside medium is still the same, 1.5. Now these are the two simplest equation in the entire universe. You should be able to solve these two equations. I'm not going to tell you how to solve them. From the first equation, you can get the value of x, or you can equate the value of x from first equation, put it in equation number 2, and you will get the value of t. I'm not going to solve it for you because then things are going to become worse. Yes, from here, these two equations, you should be able to tell me the value of t. And I think the value of t is coming as 15 centimeters. Yes or no?
Yes, sir.
How many of you could do this question? Now, please raise your hands once again. Well done. So we are making some giant steps. One small step of mankind. No. One small step of man, a giant leap for mankind. That is what I believe in. And before ending this revolutionary class, I will give you a question for homework. And maybe the girls have already seen this because they are working a lot harder than guys. So I hope that they have not seen this question. Oops. Okay. Something wrong with my clipboard. Right now the clipboard looks okay. Okay, my dear girls and boys. I hope you have not seen this question. I put it here. And here comes the question for you to do as homework. What is this? This is not good. Yes, this is the question that you got to do. A 20 centimeter thick glass slab of refractive index 1.5 is kept in front of a plane mirror. Now in the next class, this plane mirror is probably going to become a reflective concave or a convex mirror as well. As we go on, the problems are going to get a bit more tricky. A plane object is kept in air at a distance of 40 centimeters from the mirror. Find the position of the mirror with respect to the observer. What is the effect of the separation between the glass slab and the mirror on the image? So I have an observer who is going to observe this. Where will he see the image? Do we understand the question? Remember, no diagram is given in the question. So there is an object, there is a glass slab, and then there is a mirror. The object is placed somewhere, the glass slab is somewhere. And now we have to find out where is the observer going to see the image of the object. The observer is standing near the object itself. So I am the observer, there is an object, there is a glass slab, then there is a mirror, and I'm not watching the object, I'm looking at the glass slab and trying to see where is the image. Do we understand the question? Do we understand the question?
Yes, sir.
Then, sir, this is the question for you, sir, to solve it. Because if you can do this, then only we can move ahead and solve a question which instead of a plain slab, a plain mirror, it would have concave or a convex mirror. So we will try to solve that question in the next class. Anyone has written down this question? Everyone has understood the concept of real and apparent depth? Please raise your hands one last time so that I can be sure that this topic is locked, because you can have a question from this topic. This topic is done. We understand this, everyone? Okay, then we end this
Sure.
class here on this note. And I hope you have got the sheet that I have sent you. If you can solve the sheet and do the question that we are discussing in the class, it is much more than enough that you will require to clear any exam that you are supposed to face. Remember simple things. JEE only tests your simple knowledge. Take care. Have a nice day.